Okay, so what we're going to do now is we're going to apply the Dupuit equation. So this is the Dupuit, and the derivation of this was relatively straightforward. And it's important to understand the derivation in order to apply the equation correctly. And so what we're going to look at is we'll have some sort of aquifer, and that aquifer is going to be unconfined. So we'll have a water table over one side, and that is going to be our H1, and then we have a water table on the other side, and we'll say that's H2. Okay. And we're going to make this problem a little bit more complicated. We'll say that the bottom of the aquifer, so this is the bottom of the aquifer, sometimes we use this to indicate that this might be clay, and then the little dots indicate that this might be sand. So the sand would be the aquifer, and we've got water flowing from point 1 over to point 2. Okay, and so we're going to make this a little bit more complicated. We're going to say that this is elevation 550, and this is going to be elevation 600 feet. So here we're at 500 as well, right here. And then this over here, this is going to be elevation 580. Okay, so in this case, our H1 then is going to be 50 feet, and H2 is going to be 30 feet. And this is a key thing to understand, because the math will not work out. If you put your H1 as 600 and your H2 is equal to 580, it's going to do the calculations as though your aquifer were 600 feet tall, or on this side and 580 feet tall on the other, and you won't get the correct amount of flow. It'll tell you that you have much more water flowing here than you actually do, really, because we're just interested in the difference between those two, which is going to be H1 and H2. So that's kind of the critical thing, and we go through the derivation of this just to emphasize how important it is to use the right numbers here. Okay, so now the actual calculations are pretty easy. So let's say that the width of our aquifer is 1,000 feet. So that width, that's the distance going into the page, and that width is 1,000 feet. Okay, and then we can do our calculations, and we'll say that our permeability is 3.28 times 10 to the minus 4 feet per day. And that's equivalent to 1 times 10 to the minus 2 centimeters per second. But to do these calculations, we want to do everything in the same units. So this is negative k divided by 2, and then the distance between these two, so that we're going to call L. When we did the derivation, L was equal to x2 minus x1. Okay, so we'll just say that's 2L, and then we'll multiply it by h1 squared minus h2 squared, multiplied by the width, which is that 1,000 feet. Okay, and so we'll just start putting the numbers in here. So that's negative 3.28 times 10 to the minus 4, and that's feet. And I made a slight mistake over here. This is feet per second. And then our H1 is just that 50 feet squared minus 30 feet squared. And then this is all going to be divided by 2 multiplied by 1,000 feet. Okay. And then we can do the calculations, and one other thing that we are missing here is we have to multiply it by the width, which is 1,000 feet. So that's our width. So the 2,000s can cancel out, and so the total amount of flow then is going to be that 3.28 times 10 to the minus 4, and then multiply that by the quantity of 50 squared minus 30 squared, divide by 2, and then the 2,000s cancel out in this particular case, so this winds up 0.2624, and that's going to be cubic feet per second. Because notice that you've got feet squared over here, and you've got feet, and then you've got feet in the denominator, feet in the numerator. Those two are going to cancel out with one another, and so you wind up with units of cubic feet per second. And that's that's the calculation. And so what we've done here is we have calculated the amount of water that would flow between this point over here, H1, through your aquifer over a distance of 1,000 feet. And it works out to be 0.2624 cubic feet per second. And so what we're going to do next is we are going to compare this with a numerical calculation to be able to just confirm the numerical calculation and also to have better confidence that we understand what the total flow is.